The year is 1969, and a pair of brilliant Soviet astronomers discover what we now know as Comet 67P Churyumov-Gerasimenko. Now fast forward to 2014, March. The European Space Agency launches a rocket whose payload includes both an orbiter named Rosetta and a lander named Philae. Destination? Comet 67P. In August 2014, the spacecraft reaches and eventually orbits the comet. In November, its lander module Philae had a rough landing on 67P. After a system failure, it actually bounced a few times before landing in the wrong place and disoriented. But Rosetta's camera system did manage to capture some really nice images as it orbited and also as it approached its planned crash landing on the surface of 67P, which was the end of the mission. Now, let's move along to the year 2018, where I, the real Jimmy Roberts 1, the guy who some of you insist must have no life whatsoever, in the middle of all my lameness, I finally found time to look at some images of 67P Churyumov-Gerasimenko, and within only a few minutes, I knew we had a big problem here. Now look at these images. They're all of the same supposed comet. There's a lot of difference in these images, but you might say, well, Jimmy, you're not considering shading and all angles. Okay, well, consider this. Here we have the ESA's three-dimensional model that they've made available online, and you can play around with it. You can even change the lighting. But you are not going to get all of this. Now, the ESA once explained that 30% of the darker portions of 67P have not been fully analyzed yet, thus the shape model is incomplete for those regions. Well, maybe so. But perhaps they couldn't create a proper static model based on a dynamic object. That's right. I'm saying that 67P has the ability to change shapes. It transforms. It has mechanical, intelligently controlled, moving parts. I'm saying that 67P is not a comet. Now there are others who have noticed that something is wrong here. By the way, the size of this thing from left to right is 2.5 to 4 miles-ish, and I really think it depends on what shape it's taking at the time. Take a look. You think I'm just making this up? Let's look closer. Now these movements may not be exact, of course, but they're not totally arbitrary either. There are distinct points where rotary mechanics take place. Now look at this. Yeah, that's right. That's 67P, the same object. And as we peruse the surface, notice the six-sided crater and areas that are smudged or covered. A lot is masked here. Whoopsie! Movable mechanical parts are in view here, throughout this area. Points of rotation are here and here, one visible, the other implied. You think I'm crazy? Are you going to say, well, you can use Photoshop to make anything look the way you want? Okay, why would I do that? I am not here in an attempt to make you think things that are not true. I am here to get you to simply think. Another view of this monster. Pay attention to this area. These are mechanisms we are viewing. Some have questioned, what's up with that big hole that suddenly shows up in this image? Well, it's not a hole. The ESA and NASA have both touched on some of the anomalous happenings on 67P, such as how the two lobes seem to maybe be disconnected, actually moving independently of each other, how gases suddenly shoot from the inside, how a boulder appears to have moved 400 meters between images. They mention that very unusual sound frequencies are being emitted from 67P, and that there's been shifts in its movement that, for a comet, is unprecedented. Fellow humans, look at these shapes on the surface. These are artificial components, objects that serve in the functionality of this monstrous machine. Yes, there does appear to be an actual soil that covers much of this thing, but do you think that that should disqualify 67P as being a machine? Maybe 67P is millions of years old. Maybe it is defunct, out of commission, and it's attracted dirt and debris from its travels. Or maybe there is a reason why a large spacecraft like this requires a soil-like surface as, say, a type of epidermal protection. Or perhaps its function is camouflage. Our own astrophysicists seem to be stuck in a sort of mathematical quagmire. Now, for the sake of education,
we measure the abundance of ice and the temperature in different points, getting closer to the shadows. And you see an anti-correlation. When you have the maximum abundance of ice, you have the minimum temperature. As soon as the temperature increases, the ice diminishes.
We figured out where it's really cold, the water is frozen. And then when that area gets less cold, the water is not frozen. Now, in all fairness, he adds that sublimation takes place whereas we go from ice straight to a gas, skipping the water part. Indeed, that's interesting, exciting to a few, but let's be honest. How many of you are buying the "this is helping us to understand how the universe was formed" lip service we've been getting shoved up our behinds for quite some time? How thrilling and relevant is disappearing ice if you know that 67P is an artificial machine? Back in 2014, Tyler at Secure Team 10 published a video regarding 67P. He received an untraceable email from an anonymous someone claiming to work for the European Space Agency. In short, the email was a warning that 67P is not a comet, and that both the ESA and NASA were well aware of that well before Rosetta was launched. The sender attached an image, claiming it to be an original, undoctored image of 67P. Now, here is that image. And here is the publicly released image. What I find most interesting is the lack of much difference here, except for here. Okay, so there's a round object there that gets replaced with this. I really don't get it. Okay, I'll stop here. Now you can take it or leave it, your choice. But there's several roads laid out here. There's the narrow road of factual reality, traveled by very few actually. This would be the need to know lane. And then there's fantasy highway. Well, this is where most of the world travels. It's a smooth, comfy road with signs and billboards constantly reminding you that what you are being taught is fact. Now, somewhere in between these two is the lane reserved for our astrophysicists. They're very excellent drivers. They understand exactly how the engine works and can tell you exactly how long it will take to get from point A to point B. The only problem is they're going in the wrong direction. And you'd better not tell them, because they will quickly remind you that they know how the engine works and they can calculate precisely how long it takes to get there. What lane do I take? Isn't it obvious? I don't use roads.